Hi, welcome back. So we're going to pick up where we left off about the story of the critters. So just as a reminder, we have Sky, which is a blue-tailed critter, lives on an island surrounded by ocean. Poppy, an orange-tailed critter, lives on another island surrounded by the ocean. Both are endangered, so their numbers are going down. And scientists decide to breed them in captivity to see what happens and if they can save these populations. So first question is, in that second generation, what colored tails do the offspring have? So the offspring all have blue tails. So the scientists again wonder, what's going on? Will the orange tail be lost? Unfortunately, Sky and Poppy, well, they've had 100 pups. They can't reproduce anymore. But Ocean and Lucy are able to be bred in captivity. So the scientists breed Ocean and Lucy, and what happens? That's right. So 1 out of every 4 pups ends up with an orange tail. So that's great news that the orange tail was not lost. And the scientists decide that they have 3 different ideas for what happened to these orange and blue-tailed critters. So there's 3 hypotheses, and we're going to use some evidence based on our reading to figure out which one makes the most sense based on the data. So we've got hypothesis A, each critter pup got most of its tail color genes from the parent with the blue tail, only a little genetic information from the parent with an orange tail. The other hypothesis, B, says each critter pup got all of its tail color genes from the parent with the blue tail, none from the parent with the orange tail. And hypothesis C, each critter pup got half of its tail color information from each parent, but the information from the blue tail parent overwhelms the information from the orange tailed parent. Okay, so here are the gene chips that we use to model all 3 of the hypotheses. So in this case, hypothesis A shows that most of each critter pup got its tail color genes from the blue tail parent. So Sky gave most of its genes to Ocean and most of its genes to Lucy. That's why you see 2 blue and 1 orange, so 1 from Poppy. Same thing with the 3rd generation. So the babies, the grandpups, most of them come from, I guess you could say most of them come from Ocean, or most of them come from Lucy, and very little of them come from an orange-tailed critter. Now for hypothesis B, saying that each critter pup got all of its tail color genes from the blue tail parent. So Sky gave all of his tail color genes to Ocean and all of his to Lucy. Poppy did not give any genes to Lucy or Ocean. And then the same for the grandpups. All of them got all blue genes from Ocean, or all of them from Lucy. Now in hypothesis C, this is showing that each critter got half of its tail color information from each parent. So for example, Sky gave 1 blue to Ocean and Poppy gave 1 orange to Ocean. The same is true for Lucy. Sky gave 1 blue to Lucy and Poppy gave 1 orange to Lucy. So you end up getting 1 from each parent. Now in this case, that the blue tail information overwhelms the orange tailed information. So I showed this as the blue kind of covering up the orange a little bit. So even though the orange gene is there, it's kind of hidden. You can't see it. So Ocean has a blue tail and Lucy has a blue tail. Now in the grandpups, the 3rd generation, the same thing is happening. So Ocean is giving 1 gene, so let's say an orange gene to that grandpup, and Lucy is also giving an orange gene to that pup. Because there's no blue genes given by Ocean or Lucy, this grandpup would have an orange tail. And then you see the other grandpups are different combinations. Ocean giving a blue, Lucy giving an orange, Ocean giving an orange, Lucy giving a blue, and then finally Ocean and Lucy both giving a blue gene to that 4th grandpup. Now, based on the data that we have so far, we know that the first hypothesis cannot be true. So the first hypothesis A says that you can get most of your genes from one parent and less in other. But actually in reproduction, that's not true. You have to get equal amounts of genes and equal amounts of DNA from each parent. Now, the second hypothesis can also not be true, because if this is the case, you get all of your genes from one parent. Where did the orange tail go? Where's the orange genes? They disappear. So therefore, based on all of our evidence, the hypothesis that makes the most sense is hypothesis C. You get half of the information from each parent, but sometimes the orange information is hidden behind the blue, and that's why you don't see the blue tail. So it looks like the orange tail skips a generation, but actually it was there all along. It was just hidden by the gene for blue tails. So ultimately, this is our family tree. We've got 2 blue genes in Sky and 2 orange genes in Poppy, and then this is what ends up happening as we fill out the family tree. All right, so now that we know that this is the family tree and the genes that make up the whole family tree, my question now is, what if Dad had an orange tail and Mom had the blue tail? So Sky had orange and Mom had blue tail. Would the offspring be different? And if so, how? And the answer is they wouldn't be different. The tail color gene is not connected to biological sex. So regardless if Sky was the dad or Poppy was the mom, and whatever blue or orange tail color they had, the results would still be the same. And that's because the blue gene overwhelms the information from the orange gene. So we're going to learn more about this in class today.